Okay, good day. Can you hear me? Thank you. Okay. Okay. This is our second session in our Sunday's class today. So as we discussed earlier, today we are going to start heat lesson. This is a new lesson, heat. So heat means actually this is somewhat core unit in physics. Okay. Okay. Then write the topic heat. Heat. Okay. Okay, if we consider about the structure of paper, if we consider about the structure of paper, in our MCQ paper, there are around 6 to 7 MCQs in heat lesson. Okay, so if you consider about MCQ question paper, there are approximately about 7 MCQ 7. It will be vary around 6 to 7 today. There are approximately about 7 MCQs today. That means in our final paper, final mark, 1 MCQ represent 1 mark in our final paper. Therefore, there will be 7 marks in final paper in heat lesson 2. Okay, then if you consider about structured paper, but there's one question, there's one mandatory question in heat. Definitely there's a question in heat. There's a heat particle, one heat particle. Therefore, one heat particle means 5 marks. 5 marks in final paper. Then, essay question. Essay paper, there's a one question. There's a one question that means 7.5 marks. Here. Altogether, 14.5 means 21.5. Sorry, 19.5. Yes, plus 3. 19.5 marks. Approximately 20 marks, no? Alright. So you know, if you consider about mechanics, within mechanics, there will be around 23, 24, about 20, around 24 marks in mechanics. Okay. Then waves, there are about 21 to 22 marks. 21 kilogram, whether 20 kilogram, approximately. Here cannot. Approximately 65, no? Approximately 65 marks. Mechanics, waves, heat. If you consider about mechanics, waves, heat, actually you can take a B pass. B pass එකක් ගන්න පුළුවන්. grade 12 මේ lessons විතරක් අපි හරියට කරා. හරි. ඒකයි කියන්නේ physics වලට එකක් ගන්නවා කියන එක මහා ලොකු මොනවද නැහැ. කොහොමද grade 12 විතරක් වැඩ කරත් B pass එකක් ගන්න පුළුවන් මට්ටමේ තියෙනවා. හරි. Okay. Therefore, those three lessons are very, very important lessons in physics syllabus, mechanics, waves, and heat. Mechanics, waves, and heat, which is actually those are very important lessons in physics. Okay. So this is the structure of our paper. You can note down that thing. You can note down that thing. So this is the structure of the paper. If you consider about the structure of the unit, each unit, Puti. If you consider about the structure of each unit, there are several subsections. There are several subsections. First one is thermometry. Then calorimetry. Expansion. If you consider about expansion, Puti, there are three other subsections. Three subsections. One is solid expansion, then liquid expansion, and gas expansion. Expansion of gas. So under the gas expansion, we will learn about gas laws. We will learn this subject in chemistry also today. We will learn about gas laws under gas expansion. Okay. Then after that, thermodynamics. Very interesting listen. Thermodynamics. Then hygrometry. Hygrometry. Hygrometry means Pute, it is about vapor and humidity. Vapor and humidity. Then finally, mode of heat transfer. You know, there are three modes of heat transfer: conduction, convection, and radiation, Pute. But here we will learn about conduction and convection only. Radiation part will be learned in methane radiation unit, Pute. Okay. Here we will learn about conduction and convection only. Conduction and convection only. Radiation part will be learned in methane radiation unit. So this is the structure of heat lesson. Heat lesson. Megadaran. Hello. Once you finish, please give me a thumb. Okay, I finish. Well, thank you. මේක පොඩ්ඩක් මේ හීට් එක පටන් ගන්න වෙලාවෙදී පොඩ්ඩක් අහගන්න මේ හීට් ලෙසන් එක ගත්තොත් එහෙම මේකේ අපි arrangement එක පොතේ තියෙන arrangement එක කියන්නේ අපි syllabus එකේ තියෙන arrangement එක ගත්තොත් එහෙම thermometry වලින් කළා expansion ඊට පස්සේ වලින් තමයි calorimetry වලට එන්නේ. හරි. හැබැයි එහෙම කරන්න ගියොත් එහෙම පුතේ මේක ළමයිට තේරෙන්නේ නැහැ. ඇත්ත කතන්දරේ ගත්තොත් හීට් ලෙසන් එක තමයි ගොඩාක් වෙලාවට ළමයි අමාරුයි කියන ලෙසන් එක. හරි හීට් එක. හේතුව මේක ටිකක් තියරි පැත්ත ටිකක් හොඳටම තේරුම් ගන්න ඕන ලෙසන් එක. තියරි පැත්ත හරියට තේරුම් ගත්තේ නැත්නම් ආන්සර්ස් දෙන්න බැරි ටිකක් අමාරු questions එන්න පුළුවන් ලෙසන් එක. අමාරු නෑ. හැබැයි තියරි පැත්ත දැනගත්තොත් ආරම මේකෙන් හදන්න පුළුවන් හරිම ලේසි ලෙසන් එක. හැබැයි ඒකට හරියට පිළිවෙලට අර ලොජිකලි අපි තියරි ටික ළමයට දෙන්න. ඒක කරන්න බෑ ඔය කියන විදිහට මෙහෙම කිව්වොත් මේ ගත්ත ඒ පිළිවෙලට ගියොත් එහෙම ඕක කරන්නට අමාරුයි. හේතුව ඒක කිසිම ලොජිකල් ඇරේන්ජ්මන්ට් එකක් නෙමෙයි තියෙන්නේ. හරි. ඒ කියන්නේ හීට් එක කියන්නේ මොකක්ද කියලා ළමෙක්ට කියා දෙන්න නැතුව ඒක ටෙම්පරේචර් එක හීට් එක අතර වෙනස කියා දෙන්න නැතුව ඊට පස්සේ ඒ මොකක්ද කියලා කියා දෙන්න නැතුව මුලින්ම තර්මෝමීටර්ස් ගැන කතා කරලා ගියොත් එහෙම එතනින්ම ළමයට එපා වෙනවා. හරි. ඒක නිසා මම මේක කරන්නේ මගේ පිළිවෙලකට ඒක ලොජිකලි ඕගලන්ට ලස්සනට ඇරේන්ජ් කරගන්න පුළුවන් හීට් ලෙසන් එක ඊට පස්සේ. හරි. හරි. ඒ නිසා මම මුලින්ම පටන් ගන්න අපි කැලරිමෙට්‍රි වලින් පටන් ගලා ඊට පස්සේ තමයි අපි thermometry expansions start ඉතුරු ටිකට යන්නේ. හරි. Okay. Next write topic. Next write topic. Calorimetry. 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 Okay, Putin. Actually, heat. Heat is an energy that involves with internal molecular arrangement. Putin. Internal molecular arrangement. Therefore, before starting to learn about heat, we have to learn about the molecular arrangement of matter. So, first of all, we are going to learn about that molecular arrangement. Okay. So, in calorimetry lesson, we can understand that molecular arrangement and we can understand what is heat energy and what is the meaning of temperature and what is the relationship between them. So, we can understand about heat energy during this lesson. Therefore, please listen to this lesson very carefully. This is somewhat a core lesson in heat putting. Okay, there are a topic calorimetry. Then the first subtopic is nature of matter. Nature of matter. Nature of matter. Nature of matter or objects. So if we consider about any matter, Pute, suppose this pen or even this board or any matter. If we consider about any object consists of made out of a small particle, a small molecular particles. Pute. Every matter means every object is made out of very, very small molecular particles. Therefore, every object made out of those particles. In between those particles, there are intermolecular bonds, Pute. Intermolecular bonds. Intermolecular bonds. So, these particles are bonded together using those intermolecular bonds, Pute. Those particles are bonding together due to those intermolecular attraction. Intermolecular bonds means that is the attraction force in between those particles. That is the attraction force in between those particles. So, according to the strength of that intermolecular attraction, we can categorize material into three categories. Because some intermolecular attractions are very strong, Pute. Therefore, those particles are bonded together very strongly. Those kind of objects are called solid object because the intermolecular bonds are very, very strong. Those particles are strongly bonded together. Therefore, in nature, we can see them as a solid material. But some intermolecular bonds are relatively weaker than the bonds of solids. Therefore, in nature, we can see them as a liquid form. So if we consider about liquid, the intermolecular bonds between internal particles are relatively weaker than that of solid. Okay. So if we consider about gases, their intermolecular bonds are very, very weak. Sometimes we neglect them. We can neglect them because those intermolecular bonds are very, very weak bonds. Okay. Therefore, according to the strength of this intermolecular bond, according to the strength of intermolecular bond, we can see some difference in nature in some objects. Some objects we can see them as solid material. Some objects we can see them as liquid materials. Sometimes some objects are categorized under gas materials because according to their strength of intermolecular bonds. If you get that one, please say that there are no Okay. Those are intermolecular bonds. මේ ෂොට් ෆෝම් එක මම මේ තියාගත්ත ෂොට් ෆෝම් එක කලින් B කියන්නේ intermolecular bonds. මොකද මේ දැන් අපි මොකක් හරි sentence එකක් ලියාගෙන යද්දි ඉතින් ඕගොල්ලොත් ඒක උරුණා ලේසි ටක් දාලා ලියා ගන්න පුළුවන්. හරි. Okay. Then draw this figure පුතේ. Then write on this. Any object is made out of molecular particles. An object is made out of molecular particles. Those particles are bonded together. Those particles are bonded together by intermolecular bonds. Those particles are bonded together by intermolecular bonds. IMB, within the brackets IMB. Those particles are bonded together by intermolecular bonds. Those are the attraction. Those are the attractions. Those are the attractions. Those are The attraction forces. The attraction forces. Those are the attraction forces in between molecular particles. Write in another para. Depending on the strength. Depending on the strength. Depending on the strength. Depending on the strength of those intermolecular forces of attraction. Depending on the strength of those intermolecular forces of attraction, comma, there are three main states of matter. There are three main states of matter. Intermolecular bonds are relatively strong. Then the second one is solid liquid. Intermolecular bonds are weaker than solid. Gases. Gas to them. Intermolecular bonds are very weak. Sometimes it can be neglected. Sometimes it can be neglected. We can neglect the effect of intermolecular bonds in gases because they are very, very weak bonds. මෙතන අපි එනකම් පුතේ මේගොල්ලන්ගේ අර මේ තමයි ස්ට්‍රක්චර් එක දැනගත්ත නම් හරි. මම මේකම කරනවා. So if you consider about solid particles, they are bonded together and therefore they are closely packed. They are closely packed. They are closely packed. Therefore, they cannot have a translational motion. They cannot translate. They cannot translate. They cannot translate. You cannot translate in the back end because they are closely packed. They are closely packed. If you consider about liquid material, if you know liquid particles, today they are partially packed. Partial packed means there are some clusters, something like this. There are some clusters. So actually there are some enough space. There's some enough space in between those clusters. Therefore, those clusters can move. They can move. Therefore, these particles can have translational motion. They can have translational motion because there are enough space to move. Therefore, we can see a liquid. A liquid can flow with it. Liquid deකට flow වෙන්න පුළුවන්, but solid cannot flow. Solid deකට flow වෙන්න බෑ. Hey, solid material වලට mobilize වෙන්න බෑ. ඒගොල්ලෝ translational motion එකක් නැහැ. But liquid material can have a translational motion. As a result of that, we can see a liquid can flow, but a solid cannot flow. Solid cannot flow because solid particle cannot have a translational motion. Solid particles වලට translational motion එකක් නැහැ. ඒ නිසා අපිට එයා flow වෙන අපි නැහැ. මේගොල්ලන්ට ඒක තියෙනවා. මොකද මේ spaces තියෙනවානේ translate වෙන්න. ඒක නිසා අපිට පේන එයා flow වෙනවා. Is that clear? If it is clear, please raise the hand. තේරෙනවද උස්සන්න එක? Okay. Then, if you consider about gas materials, okay, they are very weak and they are very weak intermolecular bonds, and they can randomly mobilize at any direction. They can mobilize in any direction. Okay. Therefore, gas materials have very strong translational motion. Okay. If we consider about, if we compare about the translational motion of liquid and solid materials, solid particles, gas particles have very high translational motion ability. Okay. ඒක නිසා තමයි අපි පොඩ්ඩක් නැත්තම් අපි හමු පුරපත්තු වල ටක් ගාලා සූම් එකක් කියනවානේ. ඒක නිසා අපි අර ගෑස් එකෙන් අපිට බොහොම වේගෙන් particle move වෙනවා. Okay. You can do this one. Okay. Henry, have finished? Okay, now we have discussed about nature of the object. Now we have discussed about nature of the object with you. So every object is made out of molecular particle, and we have discussed about that thing. Now we are going to discuss about the nature of those particles. Particles inside that molecular structure. What is the nature of that particle? Okay, there are topic. Nature of molecular particles. Nature of molecular particles. Aku apalah online. Putih, normally, if we consider about those particles, in nature, uh, they are actually they have a motion. They have a motion at any temperature. If the temperature is not equal to absolute zero, I will let you know what is absolute zero. If the temperature is not equal to absolute zero at any temperature, they have a motion. They have a motion. They have a motion. So you know these particles cannot have a motion because they are closely packed. So in such cases, they will have a vibration. They will have a vibration. Therefore, at any temperature, they are not stationary objects, stationary items. They have a mobility. That may be a vibration. Sometimes it may be a translation. Sometimes it may be a rotation. It may be a rotation. Those particles can rotate. They can spin. Therefore, at any temperature, those are not in stationary condition. Unless the temperature is zero. Unless the absolute temperature is zero. Absolute temperature is zero. And not Celsius is zero, the absolute zero. And okay, I will let you know what is absolute zero. Therefore, if the temperature is higher than absolute zero, every particle have a motion. Every particle have a motion. It may be a vibration. It may be a vibration. Sometimes vibration plus translation. So if you consider about lipid particles, they can vibrate as well as they can transfer. Sometimes vibration plus translation plus speed, because these particles can vibrate, can translate. Mostly they are translating. And they can rotate. They can rotate too. Therefore, we can conclude one thing. If the temperature is higher than absolute zero, those particles have kinetic energy due to their motion. Is that clear? If it is clear, please raise the hand. තේරුණා තුස්සන්න. එහෙනම් මේක අදහස මොකක්ද? මේ object මේ particles වලට පුතේ absolute zero එකේ නෙවෙයි නම් මේ temperature එක තියෙන්නේ, අනිවාර්යෙන්ම kinetic energy එකක් තියෙනවා. Because all the particles have a motion. A motion if the temperature is higher than absolute zero. If the temperature is higher than absolute zero, every particle have a motion. It may be a vibration, it may be a translation, it may be a rotation. And okay. That means these particles have a kinetic energy if the temperature is not equal to zero. If the temperature is higher than zero, absolute zero, definitely those particles have an energy and kinetic energy. Okay. Okay. There are topic. The nature of molecular particles. The nature of molecular particles. At any temperature. Oh, sorry. Right under that. At any temperature, other than absolute zero, comma, every molecular particle has a motion. It may be a vibration, comma, translation or rotation. It may be a vibration, comma, translation or rotation. Okay, that depends on the strength of intermolecular bonds. If the strength of intermolecular bonds very high, then mostly it may be a solid. Therefore, those particles cannot have translational motion. In such cases, they will vibrate. They will vibrate. If some materials, actually some materials, sorry, intermolecular bonds of some materials are relatively weaker. So in such cases, those materials can translate as well as vibrate. Sometimes they can rotate. Therefore, in such cases, those materials or those particles can have the combined motion. Combined motion means translation plus rotation plus vibration. Therefore, it is a complicated thing, but anyway, a temperature higher than absolute zero, those particles have a motion. Due to that motion, those particles has a kinetic energy. That is the most important thing, and that is the thing we need. Okay. Then I know that. The type of motion. The type of motion depends on several factors. The type of motion depends on several factors. I will explain. Absolute zero के हम किया मेरे पास एक किया ये टॉपिक के था absolute zero. The type of motion depends on several factors. But ultimately, come on. When the temperature is higher than absolute zero, when the temperature is higher than absolute zero, all the particles have a kinetic energy, relevant to their motion. Have a kinetic energy relevant to their motion. Is that clear? Is that clear now? You know, due to those vibration or due to those motions, those particles have a kinetic energy. Therefore, these internal particles have a kinetic energy relevant to their motion. Is that clear? If it is clear, please raise the hand. Tena Tusan. Okay. Uh, Last sentence again. Sorry. Again, last sentence again. Gandhi. Last sentence saya ada pertanyaan sebenarnya macam really, but ultimately, uh, when the temperature is higher than absolute zero, all the particles have a kinetic energy relevant to their motions. Relevant to their motions. Again, is the okay. But ultimately, all the ultimately, when the temperature is higher than absolute zero, all the particles have kinetic energy relevant to their motion. Right? Okay. Then look at this one, Puti. Look at this one. Everyone, please look at the board. Takka bala at the board again. Now you know. Now you know. According to this explanation, it is very clear. It is very clear. When the temperature is higher than absolute zero, I will explain what is absolute zero today. When the temperature is higher than absolute zero, I got my note then absolute zero. So absolute zero, the absolute zero is the temperature, is the lowest possible temperature in the universe. That is the lowest possible temperature in the universe. Actually, we cannot reach to that temperature. The temperature is equal to minus 273.15 Celsius. We call it as 0 Kelvin. 0 Kelvin. 0 Kelvin. Okay. So absolute zero means that temperature. Absolute zero means that temperature. Actually, in absolute zero, all the particles stop their motions. All the particles will be freeze. Will be freeze means there is no motion in the particles. There is no motion in the particles. And මේ ලස්සන කතන්දර ගොඩාක් තියෙනවා මම මේක ගෑසස් ගැන කතා කරනකොට ගෑස් ලෝස් ගැන කතා කරනකොට මම කියා දෙන්නම් මේ අදුරු සීරෝස් වල තියෙන මේ ලස්සන concepts ටික හරි but remember one thing absolute zero is equal to minus 273.15 Celsius so that is the temperature that is the lowest possible temperature in the universe okay so when the temperature, if you at the temperature, all the particles stop their motion. That means there won't be any particle movement at that temperature. And that means kinetic energy. kinetic energy of particle will be zero at that temperature. Kinetic energy will be zero. Is that clear? පැහැදිලිද ඒක? මොකක්ද absolute temperature කියලා? absolute zero කිය මොකක්ද කියලා තේරෙනවද? හ්ම්? ඒවා කියලා ගහන්නේ concept එක ඇතුළේ තියෙන තව කතාවක් ටිකක් තියෙනවා නේද? value එක මොනවද? හරි. හරි. absolute zero. I will make you a note of it. මම note එක දෙනවා. නැත්නම් අර හැම වෙලේම absolute zero කියන කතන්දරේ කියනකොට ඕගොල්ලන්ට මොකක්ද වෙන්නේ කියලා හිතනවනේ. So that is absolute zero. Okay. So according to this explanation, Puti, if the temperature is higher than the absolute zero, then definitely there will be a kinetic energy inside the object. Okay. Then look at this one. Now you know, if we consider about the structure of the object, Puti, there are intermolecular bonds between them. Intermolecular attraction. Suppose if you want to remove this particle, then what should you do? If you want to remove this particle, definitely there are so many intermolecular bonds. හරියට අර අත්තල් බෙදන් ඉන්නවා වගේ නේ. කට්ටියත් එක්ක අත්තල් බෙදන් ඉන්නවා. හරිද? දැන් මට එතනින් එක්කෙනෙක් පයින් කරන්න ඕන නම් මම මොකද කරන්න ඕන? අර අත්තල් බෙදන් ඉන්න ටික මොකද කරන්න ඕන? බ්‍රේක් කරන්න ඕන. නේ? So if you want to remove this particle, definitely you have to do a work. Remember this word. You have to do a work against these intermolecular bonds. That means if you want to change the place, or position, if you want to change the position of this particle, definitely you have to do a work against intermolecular bonds. Is that clear? Clear? If it is clear, please raise the hand. And that means if you want to change the position of any particle that involves an energy, you have to supply energy. Otherwise, you cannot change the position of that particle. That means due to those intermolecular bonds, those particles have energy. That energy is relevant to change the position of that particle. It is something like what kind of energy? What energy is there? Tell me. What position එක change කරන එකත් එක්ක ඉතන energy එක මොකක්ද? Very good. It is a potential energy. It should be a potential energy. Therefore, due to those intermolecular bonds, those particles have an energy type that is a potential energy, because to change the position of particle, we have to give energy. That means that energy is required by that particle to change the position. That means that particle has that energy. That particle has that energy. Therefore, 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 there are two types of energies. There are two types of energies. One is due to the motion of those particles. Due to the motion of those particles, that motion may be a vibration, that motion may be a translation or rotation. Anyway, due to the motion of those particles, those particles have kinetic energies, and due to the intermolecular bonds, they have a type of potential energy. If you got that one, please raise the hand. Pute, that means if we consider about any object, if we consider about any object, inside that object, there's a energy storage. There's energy storage, no? Kinetic energies and potential energies. Okay, but those energies are internally stored. Therefore, we call that energy is internal energy of that particle, internal energy of that object. Therefore, internal energy of that object means that is the kinetic energy, and kinetic energy due to the motion of the particle, and potential energy due to the intermolecular bonds. Therefore, the addition of both energies are called internal energy of that particle, internal energy of that object or particle of that object. Okay. Therefore, if you consider about this object have particles. Those particles have kinetic energies as well as potential energy. So if you consider about the entire energy, we call that entire energy as internal energy of that object. Is that clear? If it is clear, please raise the hand. Okay. There is something again. Draw this one. Then write on this. Due to the intermolecular forces of attractions, due to the intermolecular forces of attraction, due to the intermolecular forces of attraction, come on, an energy should be provided, an energy should be provided to change the position of, to change the position of particles. Because an energy is required, an energy is required to break, energy is required to break the intermolecular bonds intermolecular IMB than intermolecular bonds, because energy is required to break intermolecular bonds and change the position of the particle, change the position of the particle from one place to another, to one place to another. That means, that means that means there's an energy, there's energy, that means there is an energy, that means there is an energy relevant to the current position of particles. Relevant to the current position of particles. As this energy involves, as this energy involves, as this energy involves with changing position, come on. It will be a type of potential energy. It will be a type of potential energy. Okay, write on that. Write in another column. Therefore, inner particles have a potential energy due to intermolecular bonds. Inner particles have a potential energy due to intermolecular bonds. Okay, then our topic internal energy. Internal energy of now. Okay. Internal. So what is internal energy? So as we discussed earlier, particles have two types of energy. One is a kinetic energy due to their motions. Second one is potential energy due to intermolecular bonds. So if we take the total energy, if we take the total kinetic energy plus potential energy, those are internal energy. So the total energy involved with internal kinetic and potentials are called internal energy of that particle. Okay. Pay right topic. So write on this. According to the nature of inner particles, according to the nature of inner particles, according to the nature of inner particles, they involve two types of energies. Two types of energies. First one is kinetic energy due to their motions. Second one is potential energy due to intermolecular bonds. Kinetic energy due to their motions, then potential energy due to intermolecular bonds. The sum of those two energies, the sum of those two energies the sum of those two energies inside an object, sum of those energies inside an object is called the internal energy of that particular object is called the internal energy of that particular object. The internal is equal to internal kinetic energy plus internal potential energy. Internal energy is equal internal kinetic energy plus internal potential energy. All right. Another thing. Okay. අද දැන් අර ඔයගොල්ලෝ මේ අපි අර ඉවර වෙච්ච පාඩම් වල ඉවර වෙච්ච මොකද්ද අපි දැන් ඉවර කරානේ පුතේ මැකැනික්ස් වල සර්කියුලර් මොෂන්ස් වල නම් ඉවරයි. දැන් එතකොට ඒ ඉවර වෙච්ච පාඩම් වල past papers MCQ past papers essay ඒ questions කරන්න ගන්න ඉන්න පයි questions ටික කරන්න ගන්න සමහරවිට අපි තාර්ගය කරනවා තාර්ගය කරා කියලා වැඩි වෙන්නේ නැහැ. ඒ නිසා මොකද මේ හදන ෂෝට් මෙතඩ්ස් ටික ඊට පස්සේ හදන ඒ ක්‍රම ටික මතක තියෙන එක වඩා හොඳයි. මොකද ආයේ වගේ අනකවත් ආයි අලුතෙන් හදන දෙයක් නෑ ඕක දන්නවා ඕනේ හැදුවා. හරි. ඒ නිසා ආයෙ හදනකොට තියෙන ප්‍රශ්න වෙන්නේ හදන්න පටන් ගන්න. ආයි පස්සේ මං කරනවා කියලා ඉන්න එපා. අපි කරනකොට ඉතින් මං කරන්නේ මගේ ෂෙඩියුල් එකේ හැටියට. එතකොට ඊට කලින් ඕගොල්ලෝ කරලා තියෙන එක හොඳයි. හරි. Okay. Then we have discussed about internal EBITDA. Now we'll discuss about absolute zero. There are special note, make special note taken there. Special note. Absolute zero. Absolute zero. What this? Absolute zero is the lowest ever temperature in the universe. Is the lowest ever temperature in the universe. At this temperature, every particle in an object stops their motions. Absolute zero is equal to the minus 273.15 Celsius. Okay. And this is says in Celsius scale. Okay. So that's another scale, the thermodynamic temperature is measured by Kelvin, no? According to your knowledge in unit independence, Kelvin is our main unit, SI unit made of temperature. So minus 273.15 Celsius is equal 0 Kelvin, 0 Kelvin. Therefore, we call Kelvin as the absolute scale. Absolute scale. Okay. Now it is very clear. Minus 273.15, or normally we call it as 273. Celsius is equal 0 Kelvin. Okay. Therefore, if you add 273.15 to both sides, if you add 273.15 to both sides, this will be 0. This will be 0. Therefore, 0 Kelvin is equal to 273.15 Kelvin. 273.15 Kelvin. 0 Celsius is equal to this one. Okay. Therefore, if you add 273.15 to Celsius scale, you will have Kelvin scale. That means if you add 273.15, 273.15, or approximately 273 to Celsius scale, you will have the Kelvin scale. You will have the Kelvin scale. If you add 273.15, then you will have the Kelvin scale. That means, suppose 27 Celsius is equal to 27 plus 273 Kelvin. 27 plus 273 Kelvin, that means 300 Kelvin. 300 Kelvin. Ilagata 47 Celsius is equal 47 plus 273 Kelvin. That means here 320 Kelvin. Therefore, if you are given a Celsius scale, you have to add 273 to convert it into a Kelvin scale. Is that clear? If you got this one, please raise the hand. You know also. Okay, thank you. Make that. Okay. Harmonic. Now we have discussed the structure of matter. Structure of matter means the structure of object. So every object consists of some molecular particles. Then in between them there are intermolecular bonds, and according to the strength of intermolecular bonds, we can divide the matter into three states: solid, liquid, and gases. Okay, likewise, we have discussed the internal arrangement of objects. Internal arrangement of objects. So, according to that internal arrangement, finally we conclude there are two kind of energies involved with internal particles. Okay, those energies are kinetic and potential energies. Therefore, we call them as internal energy. Total energy is call it as internal energy. Therefore, if we consider about any object has a energy, has energy. This is not only a matter, this is not only a matter. No? If you see this one, actually you can see this one as a matter, but this is not only a matter. Inside this object, there is energy. අදක තියාගන්න එනර්ජි එකක් තියෙනවා. හරිද? බොහොම ලස්සන කතන්දර ටිකක් තියෙනවා මේ ඉස්සරහට මැටර් රිලේෂන්ස් පරිදි මේ කතා කරනවා. පුතේ ඔය මැටර් එකයි එනර්ජි එකයි. මැටර් එක එනර්ජි එකක් ගත්තොත් එහම ඔය තුනේ කෝරිලේෂන් එකක් තියෙනවා. හරිද? මේ කෝරිලේෂන් එකක් තියෙන අපිට ඕනම මැටර් එකක් එනර්ජි එකක් බවට කන්වර්ට් කරන්න පුළුවන්. හරිද? नहीं था ना मटेरियल केमिकल बहुत करने पर बस आयतन मटेरियल काय नव्हतं तो करेल आयतन मटेरियल काय नव्हतं मटेरियल काय बहुत ही नहीं मटेरियल एनर्जी आप इधर करने तुम्हारे पास से आयतन तो मटेरियल का किंग लगता है आय मटेरियल किंग नहीं था हाँ इतना नहीं का तंदुर दिला हाँ हाँ ओके मैं इतना बोले मैं इतनी का ना रिस्पॉन्स करेंगे हाँ okay. Then that means every object has an internal energy. Now, then what is the meaning of heat? What is the meaning of heat? That is heat, Pute. That is heat. That means if any energy can change the internal energy of an object. If any energy can change the internal energy of that object, we call it as heat, Pute. Therefore, that is heat. Heat means that involves with internal kinetic and internal potential energy. It involves with internal kinetic energy and internal potential energy. Therefore, heat means that is a type of energy. That is a type of energy that can change the internal energy of a matter. That means if we supply heat to an object, their internal energy can be changed. On the other hand, if heat energy is removed from an object, again, the internal energy of that object will be changed with it. Therefore, heat means it is a type of energy. That can change the internal energy of an object. That means if we supply heat energy, internal energy of object can be increased. If we remove heat, from an object, the internal energy of that object will be decreased. Is that clear? Heat means that is a type of energy that can change the internal energy. Is that clear? If it is clear, please raise the hand. Okay. Then write a topic heat. Heat or thermal energy. Heat or thermal energy. Heat or thermal energy. Suppose now there is an object with you. So if we supply heat or if we provide heat energy to an object, its internal energy, this will be increased. On the other hand, if we remove heat energy, from an object, its internal energy will be decreased. Therefore, heat means there is a type of energy. There is a type of energy that can change the internal energy of an object. Okay. On the other hand, actually, heat means that is consist of internal energy. Internal energy के में कमा क्या दिली थी? That is consist of internal energy. Okay, then draw this one. The internal energy के में හැදිච්ච නිසා තමයි මොකද වෙන්නේ? ඒක heat එක අපි දෙනකොට internal energy change වෙන්නේ. That is the reason when you supply heat energy to an object, its internal energy will be changed. So that is the reason. Oh, sorry, Bhute. Is there any lagging with the video? Video lag වෙනවද? අනිත් අයට වීඩියෝ එක ලැග් වෙනවද කියන සවුන්ඩ් එක ලැග් වෙනවද දන්නේ නැහැ නේ. මම නැත්තම් මේ ආන්සර් එකක් දෙනවනේ කට්ටිය. මම අර වීඩියෝ එක ලැග් වෙනවද කියලා අහපු සවුන්ඩ් එක මම හිතුවේ තාම ඇහිලා නැහැ. Now okay means previously it is not okay. Listen to what is about your status? Is that okay now? Or is still lagging? Ah. Now okay, no? මම අර කියපු දේ මම මොකක් හරි අහිච්ඡන්තයක් තියනවාද මම අර මේ කලින් දීපු නෝට් එකේ මොකක් හරි ලියා ගන්න බැරි වෙච්ච තරක් තියෙනවා. නෝට් එකේ හරි මොකක් හරි ඉන්කම්ප්ලීට් වුණාද මම අතන මට නෝටිස් උත් නැහැ ලැබුණා කියලා. එහෙම දෙයක් වුණාද? Morning. Thank you. And okay. Then I will start. The type of energy, the type of energy that can change the internal energy, that can change the internal energy of an object is called heat, is called heat or thermal energy, is called heat or thermal energy. So that is the meaning of heat Uday. And therefore, heat means that is not a big deal, but heat means that involves with the internal energy Uday. Actually, that consists of internal energy. That is the reason, when we supply a heat energy, the internal energy of that object is increased. That is the reason when we remove heat energy from an object, the internal energy of that object decreases. Okay. They went on that. Write in another para. That means when, that means comma, when heat energy is supplied to an object, heat energy is supplied to an object, its internal energy will be increased. Its internal energy will be increased. If heat energy is removed from an object, its internal energy will be decreased. Pute. Its internal energy will be decreased. Pute के लिए होगा. हाँ. Look at this one. Now we need to identify. Now we know what is heat energy. Heat energy. Now, what is temperature then? What is temperature? What is temperature? Okay. So suppose there's an object. There's an object. And suppose we touch this object. Are we going to touch it? There's a man and he touched this object. And now we are going to give a heat. Heat means now we are going to heat up this material. Okay, using a Bunsen burner or something. Now we are going to heat up or give a heat to this material. Then what will happen to this sand? What will happen to this sand? Then definitely when the heat energy is given, this man can feel the hotness. No? He can feel the hotness. He can feel something. Okay. On the other hand, on the other side, if we decrease or if we remove the heat, means sometimes we can pour some ice water into this material. Okay. Likewise, if you remove the heat energy, we can feel the coldness. We can feel the coldness. When the heat is supplied to this object, we can feel the hotness. We can feel the hotness. Now we can understand how that is happening. Okay. Shall we discuss that thing? How will we discuss that? That is temperature. That is temperature means we can feel that thing. We can feel that thing. That is temperature. Okay, now we can understand. Now we can discuss how that is happened. Then that topic, temperature. Temperature. Suppose we supply a heat energy. We supply heat energy to this structure. So now we have to understand what will happen when heat is supplied to a structure or to object. You know, heat means that consists of internal energy, Bhuti. Heat consists of internal energy. So, if heat is supplied, what will happen? The internal energy of these particles, of this structure, can be changed. And but you have to understand that thing. Bhuti, when heat is supplied to a structure, the first thing, the first of all, its kinetic energy will be changed, Pute. Its kinetic energy will be changed. Suppose this is a solid structure. If it is a solid structure, now it is vibrating, Pute. Now it is vibrating. So when heat is supplied, the amplitude of the vibration, that means they will vibrate fastly than the first occasion. Initially, the vibrations are it has a somewhat low amplitude. But when heat is supplied, the frequency and the amplitude of vibrations will be increased. Therefore, the kinetic energy involved with those particles increase. So when heat is supplied to this object, what will happen? First, the kinetic energy of those lattice will be increased. It will be increased. That is the first thing happen to it. ඒක තමයි මුලින්ම වෙන්නේ. මොකද වෙන්නේ? heat energy එක දීපු ගමන් මොකද වෙන්නේ? මේගොල්ලන්ගේ emotions වැඩි වෙනවා. දඟලන එක වැඩි වෙනවා. හරිද? කලින් මේගොල්ලෝ නිකන් අත්තල් බැඳන් ඉන්නේ. අත්තල් බැඳන් ඉන්න උන්ට මොකද වෙන්නේ? දඟලන්න පටන් ගන්නවා. පුළුවන් තරම් මේ. එහෙනම් මොකද වෙන්නේ? Kinetic energy of that lattice will be increased. Okay. Put it that change of kinetic energy, the changing kinetic energy, we can feel the changing kinetic energy through the temperature difference. The temperature difference. Actually, temperature difference means that is a sensation. That means it is a feeling. It is a feeling. It is not a property. But it's a feeling. It is a sensation. How can we sense that thing? How can we sense? When heat is supplied to a material, to an object, what will happen? The kinetic energy of those particles will be changed. That change is externally sensed as a difference in temperature. Therefore, if you feel a difference in temperature, that means there is a heat exchange. Due to this heat exchange, the kinetic energy of that object either will decrease or increase. If you feel more hotter than the previous case, that means that object absorb heat energy and increase their kinetic energies. If you feel more cooler than the first case, that means the object release or remove heat from the lattice. Due to that heat loss, the kinetic energy of those particles will be decreases. So it will be sensed as a cooling of object. Okay. Therefore, the temperature means that is a sensation. That means it is a sense. It is a sense. Okay. But it can be measured. But although it can be measured, it is a sense. It is a sense. And actually, that is due to the difference in kinetic energy. That sense is occurred due to the difference in kinetic energy of those particles. Is that clear? If it is clear, please raise that. And thank you. එහෙනම් මොකද වෙන්නේ? අපි heat එක දීපු ගමන් මුගේ kinetic energy එක වෙනස් වෙනවා. ඒ වෙනස් වෙන kinetic energy එක පුතේ අපිට sense වෙනවා temperature difference එකක් විදිහට. හරි? අපිට කලින් තිබ්බට වඩා ටිකක් අර හොට් ගතිය වැඩි නේ හොට් ගතිය එන්නේ වැඩි වෙනවා නම් ඒකේ තේරුම මොකද්ද? මූ හීට් එනර්ජි එක ඇබ්සෝබ් කරනවා. හීට් එනර්ජි එක ඇබ්සෝබ් කරලා කයිනටික් එනර්ජි එක වැඩි කරගන්නවා. ඒ කයිනටික් එනර්ජි එක වැඩි කරගන්න එක අපිට සෙන්ස් වෙනවා ටෙම්පරේචර් වැඩි වීමක් විදිහට. කයිනටික් එනර්ජි එක අඩු වුණොත් අපිට ඒක සෙන්ස් වෙනවා ටෙම්පරේචර් එක අඩු වීමක් විදිහට. පැහැදිලිද? Okay. Then write up this. මේක අපි තියාගමු. මේක අඳගන්න. Then write on this. When heat is given to an object, when heat is given to an object, comma, the first thing, the first thing, the first thing that happens is the increase of kinetic energy. The first thing that happens is the increase in the kinetic energy. Is the increase in the kinetic energy. Increasing the kinetic energy of the particles of the particles of the particles that receive heat energy, that receive heat energy. The changing internal kinetic energy, the changing internal kinetic energy the change in internal kinetic energy of particles is externally sensed as a change in the temperature of the object, as a change in the temperature of the object. When the particle receives heat energy, when the particle receives heat energy, their kinetic energies will be increased. Their kinetic energies will be increased. It will be sensed as an increment in temperature. It will be sensed as an increment in temperature. When heat energy is removed, when heat energy is removed from an object, the kinetic energies of particles, the kinetic energies of particles decreases. The kinetic energies of particles decreases. It will be sensed as a decrement in the temperature. It will be sensed as a decrement in the temperature. Okay. Now, they write under another para. Make a photograph balagin. Therefore, come on. Temperature is an external sensation. Therefore, the temperature is an external sensation that depends on the internal kinetic energy of particles. Therefore, the temperature is an external sensation that depends on internal kinetic energies of particles. Okay. That means Bhutan. So if we consider about heat, what is the heat? It means it is a energy that can change the internal energy. Energy, type of energy. It is a type of energy. It is a type of energy that can change the internal energy of an object. Then temperature. What is temperature? It is a external sensation. External sensation that depends on internal kinetic energy. Okay, internal kinetic energy. That means if internal kinetic energy changes, definitely you can feel it or you can sense it through a temperature difference. Right. Okay. The next topic is what happens when heat is applied to an object. හරි. බලමු මොකද වෙන්නේ කියලා නේ. හොඳයි අපිට බලන්න. Everyone, please look at the board. This is very very important part. හරිද පුතේ? මේ part එක මාරම important part එකක්. මේක ඇතුලේ අපි කතා කරනවා phase change වෙනකම්ම කතා කරනවා. හරිද? phase change එක වෙනකම්ම වෙන විදිය මේක ඇතුලේ කතා කරනවා. ඒ නිසා මාරම important part එකක්. හොඳට අහන්න. හරි. බලන්න. Now, this is about structure. And suppose we supply heat energy. We supply heat energy to this lattice. We supply heat energy to this lattice. Then what will happen? Heat means puthe it is a type of internal energy. That means heat consists of heat energy. Sorry, heat consists of internal energy. Therefore, if heat energy is supplied to an object, its internal energy will be changed. As we discussed earlier, the first thing happen is, what will happen? Using those heat energy, the kinetic energy of those objects will be changed first. Initially, potential energy will not be changed. What will happen? By taking the heat energy, the movements of those particles will be increased. That is the first thing happen. Okay. Movements of those particles will be increased. Suppose this is a solid material. Solid material means that now what will happen? Vibrations of those particles will be increased. Now we are going to supply heat more and more. Then what will happen? Then that energy will be absorbed by those lattice more and more. That means it will absorb more heat energy. When the absorbed heat energy increases, the vibration also increases. That means the kinetic energy of those particles increases to the. Therefore, we can externally feel or sense the temperature of that object gradually increases. When heat is supplied to that object, what will happen? Its motions will be increased. As a result of that, kinetic energy will be increased. As a result of that, the temperature of that object increases. Is that clear? If it is clear, please raise the hand on tusan. Makadunikin. Objected heated na makadunikin tira tusan. Agar dirong ganne. Objected heat take deepu kaman. A heat take absorb karagata particles heat take absorb karan. What will happen? The kinetic energy increases. That increased kinetic energy can be sensed as an increment in temperature. Therefore, as a result of that, we can sense or we can feel the temperature of that object increases. Is that clear? If it is clear, please raise the antenna to Sunupati. Thank you. Okay. That means when heat is supplied to an object, the first thing happen is the kinetic energy of that particle increases. As a result of that, temperature of that object increases. And then what will happen? That means this supplied heat means this supplied heat is absorbed by those particles, and that heat energy is totally used to increase kinetic energy. Now this particle has a kinetic energy plus potential energy. Kinetic energy plus potential. So initially, this supplied heat is used to increase this kinetic energy. Therefore, as a result of that, the kinetic energy will be increased. The potential energy remains unchanged, but kinetic energy increases. As a result of that, temperature of that particle will be increased. So still the potential energy remains unchanged today because now still there are intermolecular bonds. Now what will happen? What will happen? As the heat energy increases further, the vibrations also increases. The vibration also increases. මම කලින් කිව්වනේ පුතේ මේක නිකන් අර අත්තල් බඳගත්ත ළමයි ටිකක් කිලිතන්නේ. අත්තල් බඳගත්ත ළමයි ටිකක් කිලිතන්නේ. අත්තල් බඳගත්ත ළමයි ටිකක් කිලිතන්නේ. දැන් මම මේ අත්තල් බඳන් ඉන්නවා. දැන් මම මගේ මේ ভাইබ්‍රේෂන් එක එන්න වැඩි කරගන්න. එන්න වැඩි කරගන්න. මොකක් වේද? මම මගේ ভাইබ්‍රේෂන් එක වැඩි කරගන්නකොට එක අවස්ථාවක් වෙනවා මට තව දුරටත් මෙයාගේ අත අල්ලන් ඉන්න බෑ. තව දුරටත් මෙයාගේ අත අල්ලන් ඉන්න බෑ. මම ඒ තරම් වේගෙන් ভাইබ්‍රේට් වෙනවා. අන්න ඒ වෙනකොට මොකද වෙන්නේ? ඔන්න අත්තල් ගැරේන පටන් ගන්නවා. ඒ වගේ තාම තියෙනවා. And when heat is supplied, the vibration of those particles increases further. As a result of that, there will be a point those intermolecular bonds cannot bear those vibrations. As a result of that, those intermolecular bonds start to break. They will start to break, Puti. And then what will happen? Then this supply heat, at that moment, this supply heat will be totally utilized to break those bonds, Puti. To break those bonds. So as a result of that, after that point, the supplied heat, the provided heat will be totally utilized to break the bonds. Therefore, after that point, the supply heat won't be used to change the kinetic energy. It won't be used to change the kinetic energy. It will be used to change the potential energy by breaking the bonds, Puti. So as a result of that, during this bond breaking condition or bond breaking process, Puti, kinetic energy will not be changed. That means temperature will not be changed, because kinetic energy, actually temperature depends on kinetic energy. As the kinetic energy is not changed, that means temperature also remains unchanged. So at this position, initially, now there's object. Now we supply heat energy. Why it supply heat energy? Then what will happen? Putin? Initially, what will happen? Kinetic energy of this particle increases. Using this heat energy, the supply heat energy totally utilized to increase the kinetic energy of particles. So during this process, potential energy remains unchanged. It remains unchanged. K constant. Potential energy remains unchanged. So as a result of that, temperature of this object increases. temperature of this object increases. And then හරියට අර අත්තර බඳගත්ත කට්ටිය මොකද වෙන්නේ? දැන් vibration එක වැඩි වෙනවා. vibration එක වැඩි වෙනවා. vibration එක වැඩි වෙනවා. එහෙනම් මොකද වෙන්නේ? Now there is a point. The vibrations come to a maximum limit. Now those bonds cannot bear that vibration, පුතේ. ඒ තරම් වේගින් මේ vibration එනවා. And those bonds cannot bear those vibration. Therefore, what will happen? The bonds start to break. Now there is a point where the bonds start to break. Now we are supply heat. Now vibration cannot be bared by bonds. Now they start to break. Bonds. They start to break. Vibrations cannot be bared by bonds. They start to break. Okay. So during this process, the supply heat is totally utilized to break those bonds, Puti. Supply heat totally utilized to break those bonds. Therefore, during this process, heat is totally utilized to break bonds. So as a result of that, kinetic energy remains unchanged. The kinetic energy during this process, kinetic energy will not be changed because the supply heat will not be used to change the kinetic energy. Now bonds start breaking. When the bonds start to break, the supply heat will be totally utilized to break the bonds. So during this process, this heat, therefore, during this process, what will happen? During this process, kinetic energy remains unchanged. Kinetic energy is a constant, but potential energy change. Potential energy change because bonds start to break. You know, now kinetic energy of those particles will not be changed. As a result of that, during this process, Puti, temperature is a constant. During this process, temperature is a constant. Therefore, temperature is a constant. Temperature is constant. But the object absorb heat. Puti. The object absorb heat, but we cannot observe a temperature increment. We cannot observe temperature increment, but this object absorb heat. That heat is utilized to break the bonds. That heat is utilized to break the bonds. So therefore, externally, we cannot observe any temperature difference. We cannot observe any temperature difference, but yet this object absorb heat, absorb lot of heats. Okay, absorb heat. So due to this bond breaking, due to this breaking of bonds, what will happen? What will happen? What will happen? The state of this matter. Initially, we have considered a solid material, Pute. So due to this bond breaking, what will happen? The solid will be converted into a liquid. It will be converted into a liquid. Therefore, during this bond breaking process, there won't be any temperature difference. But yet, heat is absorbed by the object. That absorbed heat is utilized to break the bond. Due to breaking the bonds, what will happen? What will happen? The state of the matter, the state of the matter will be changed. The state of the matter will be changed. If it is a solid, it will be converted into a liquid. Therefore, we call this process as a phase change. We call this process as a phase change. That means it is very clear during a phase change. During a phase change, temperature is a constant. Temperature is a constant. During a phase change, bonds are breaking. So, supply heat is utilized to break the bonds. So, temperature is a constant. So, during a phase change, temperature is a constant, but object absorb heat. We call that heat as a latent heat. You may know that word පුතේ latent heat. අහලා තියෙනව නේද latent heat කියන්නේ මොකක්ද කියලා? latent heat එක එකේදී temperature difference එකක් නැහැ කියලා මම හිතන්නේ අහලා ඇති සමහර වෙලාවට. අහලා තියෙනවද temperature latent heat කියන්නේ මොකක්ද කියලා? ඒක තමයි. ඒක තමයි. Latent heat means that is the heat absorbed during a phase change. That is the heat absorbed during a phase change. So actually that is the energy, but that energy is totally utilized to break the bonds. Therefore, kinetic energy, there won't be any kinetic energy increment. As a result of that, we cannot observe a temperature difference, but yet there's a energy absorption. Is that clear? If it is clear, please raise the hand. Okay, then write this one today. Okay, now you can draw this one. Well, Okay, let me write this down. As mentioned earlier, comma, when heat is supplied, to an object, as mentioned earlier, when heat is supplied to an object, comma, the kinetic energy of particles, the kinetic energy of particles first increase. Since the kinetic energy, since the temperature depends on the kinetic energy, since the temperature depends on the kinetic energy, already you have to draw the chart also. Chart again. Chart එක ඇඳලා නැත්තම් අන්තිමට අඳින්න එක ප්‍රශ්නේ නැහැ. මම අකනතු තියන chart එක ඇඳලා නැත්තම් අන්තිමට අඳින්න. හරි? ඒ දෙක එකයි නේද? chart එක ඇඳලා නැත්තම් අන්තිමට අඳින්න ඕනේ. note එක ලියන්න. Okay. Then uh, since the temperature depends on kinetic energies, since the temperature depends on kinetic energies, an increase in temperature, can be observed here. An increase of temperature can be observed here. Right under another para. Make a real about that. Getting it again. Therefore, when heat is provided to an object, the first observation is The first observation is increasing temperature. Increasing temperature. Okay, underline that sentence. Write in another para. On further application of heat, on further application of heat, on further application of heat, comma, the particles vibrate. The particles vibrate more and more comma, hence the temperature increases gradually. But as the vibration increases, as the vibration increases, as the vibration increases, comma, there comes a point, there comes a point where it is no longer possible, where it is no longer possible where it is no longer possible to haul the particles, to haul the particles by intermolecular bonds, by intermolecular bonds. Right in the para. At this point, at this point, the intermolecular bonds start to break down. The intermolecular bonds start to break down. From this point onwards, the supplied heat is totally utilized to break bonds. Is totally utilized to break bonds. Is totally utilized to break bonds. As a result of that, kinetic energy remains unchanged during this process. As a result of that, kinetic energy remains unchanged during this process. Okay, I will repeat it again. The supplied heat is totally utilized to break bonds. The supplied heat is totally utilized to break bonds. As a result of that, kinetic energy, KE, remains unchanged. Okay. Therefore, the temperature of the object remains unchanged during this process. Therefore, the temperature of the object remains unchanged during this process. But heat is absorbed by the object to break bonds. As a result of breaking bonds, as a result of breaking bonds, the object will be converted into another state. The object will be converted into another state. Itu මොකක්ද මගේ අන්තිම sentence එක කරනවා තිබි. දැන් මම කියපු sentence එක කරනවා. No, thank you sentence. Last sentence.
The object will be converted into another state.
Sorry, what?
The object will be converted into another state.
Another state, huh? This process is called a phase change. This process is called a phase change. This process is called a phase change. Therefore, during a phase change, the temperature is a constant. Therefore, during a phase change, the temperature is a constant. But the object absorbs heat, but the object absorbs heat but the object absorbs heat to break intermolecular bonds. To break intermolecular bonds. That heat, that heat, that heat, that heat is called a latent heat. A latent heat. That heat is called a latent heat. ගුප්තතාවය කියලා කියනවා. ගුප්තතාවය කියලා සිංහලෙන්. ගුප්තයිනේ. අපි දන්නේ මොකක් වෙනවද කියලා. හැබැයි මොකද මේ ටෙම්පරේචර් එකට සෙට් නැහැ. ඒ නිසා හීට් එක ගත්තද කියලා දන්නේ නැහැ. හැබැයි හීට් එකක් කරා. ලොකු හීට් එකක් කරගන්න. ඒකට අපි කියනවා ස්ටීම් එකකට එහෙම මේ අපි අතහැරලොත් එහෙම අපි ගොඩක් ලොකු ඩැමේජ් එකක් වෙන්නේ ඒකනේ. ඒ ස්ටීම් එකේ තියෙන එනර්ජි එක ගොඩක් වැඩි. මොකද එයා අර ලේටන් හීට් එක ඇබ්සෝබ් කරලා ඉන්නේ. ටෙම්පරේචර් එක වැඩි වුණ නැති වුණාම ලේටන් හීට් එක ඇබ්සෝබ් කරලා ඉන්නේ. හරි. ඒක නිසා 100 සෙල්සියස් වතුරකින් පිච්චෙනට වඩා 100 සෙල්සියස් ස්ට්‍රීම් එකෙන් පික්චර් එක ටිකක් දරුණු. හරි. Yes, okay. Yes, okay. Okay. So after fully conversion into another state, again that object act as another object putih. Then again it will absorb heat. It will absorb heat. By absorbing heat, the kinetic energy of that object will be increased. Then again the same process will be repeated until the next phase change is occurred. And therefore, suppose this is solid putih. Now solid is converted into a liquid. Now liquid means another material. So after fully conversion of the solid into a liquid, then it will act as another material. Then once we supply heat to that liquid, what will happen? That liquid will absorb that heat and its kinetic energy increases. Its kinetic energy increases, and this process will be repeated. Kinetic energy increases until a certain point. So after reaching a certain point, the kinetic energy cannot be borne by the intermolecular bonds. Then intermolecular bonds start to break. Then what will happen? Intermolecular bonds start to break. Then there will be another phase change. Okay. Is that clear? If it is clear, please raise the hand. Therefore, Tusan. Dilalanga Tusan. Okay. අපි පුතේ දැන් එහෙනම් මෙතන අපි මූලික කැලරිමෙට්‍රි වල මූලික අපි කතා කරන ඔය තියරි පාර්ට් එක මෙතනින් අපි කියන්නේ කතා කරලා තියෙන්නේ. ඊට පස්සේ අපිට කතා කරලා තියෙන්නේ ඊක්වේෂන් එක බ්ලිට් කරන විදිය Q equal MC theta කියන එක. ඔයගොල්ලෝ දන්නවා ඒක ඊක්වේෂන් එක. හැබැයි ඊක්වේෂන් එකෙන් මම හිතන්නේ ඔයාලට මහ ලොකු ඊක්වේෂන්ස් හදන්න නැතුව ඇති. දැන් අපි පොඩ්ඩක් ඒක ඩීප්ලි ඇනලයිස් කරනවා. Q equal MC theta කියන ඊක්වේෂන් එක. ඒ නිසා අපිට next week එකේදී අපි ඒක derive කරලා එකකින් questions හදනවා. හරි. Okay. Do you have any question or do you have any unclear thing up to this? Do you have any unclear thing? Because this is fully theoretical part. Okay, this is a fully theoretical part up to now. So after that, in our next session, we can do some calculations. But until then, we have to understand fully about this processes. Okay. Did you get that thing? If you get that thing, please raise the hand. May I kata karute tika gatta na Atusan? Thank you. Thank you. Okay. Hello, Shashmi. Thank you. Thank you. Okay. එහෙනම් මට මේක කියලා තියෙන ආකාරයක් මේක go through කරන්න go through කරන්න ලියාගෙන බැලුවෙච්ච දේක් තියෙනවා පොඩ ලියා ගන්න අවශ්‍ය කෙනෙක් ඉන්නවනම් මේක screenshot එකක් පොන්න දාගන්න ඊළඟට මට මේකේ note එක පොඩ්ඩක් එවන්න ඕනේ හැමෝම tube submission group එකේ තියෙනවා please upload your notes into the tube submission group so I can correct you are not notes වල correct කරන්න පුළුවන් මොකද මේක theoretical part එක ගොඩාක් තියෙන තැන theoretical part එක ගොඩක් තියෙන තැන පුතේ නිසා බැරි වෙලා හරි වැරද්දක් ලියාගත්තොත් අන්තිමට exam එකට ගිහිල්ලා පාඩම් කරනකොට තමයි වැරද්ද හොයාගන්න බැරි වෙනවා හරිද ඒ නිසා නෝට් එක පොඩ්ඩක් දාන්න මට බලන්න. හරි. නැත්නම් මම බහුත එළියගෙන නැහැ නේ. පිළිවෙත. Have. Okay. Then we can complete today's lesson. If you have any questions now, this is the time to ask. Do you have any question? Do you have any questions to ask? Then I the question that I think about the hand money. To do hand that. Thank you. Okay. So now we can complete today's class. Okay, then our next class will be on next Tuesday. It is about waves. Okay. So until then, we can complete today's lesson. Everyone, good night. Everyone.
Thank you, sir. Good night, sir.
You're welcome, Pute. You're welcome, Pute. You're welcome, Pute. You're welcome.